The objective of this lesson is to have students organize data into a bar graph using a scale greater than 1 and interpreting the results. This lesson goes deeper into deciphering graphs with a scale greater than 1. Students are tasked with visualizing and building bar graphs with more difficult scaled values. Do you remember at the beginning of 2014, companies in the United States stopped production of standard light bulbs? This was to encourage people to use efficient bulbs and use less energy. This also helped to reduce energy costs. Let's look at a chart of data concerning lumens and watts. Lumens are how bright a light is, and watts, or the abbreviation W, describes how much electric energy something uses. If we want to graph this chart, what would our x-axis be, and what would our y-axis be? Let's first start by graphing the first column showing the energy needed to produce a brightness of 250 lumens. Let's make our x-axis the type of bulb and the y-axis the number of watts. To produce a brightness of 250 lumens, the standard bulb uses 25 watts, the halogen bulb uses 18 watts, the CFL bulb uses 6, and the LED uses 4. What would be an appropriate scale to use for our graph? If we use a scale of 1, the graph will be very large. So how about a scale of 2? I label my y-axis with the values of 2 and then draw my bars. 25 watts for the standard bulb. That would be halfway between 24 and 26. 18 watts for the halogen bulb, 6 watts for the CFL bulb, and 4 watts for the LED bulb. Could someone who hasn't seen the lumens chart understand what this graph is about? Is the value of each bar clear? What can you tell from the graph? Let's try graphing the information for 450 lumens. I draw my x-axis and label the types of bulbs. The standard bulb uses 40 watts, the halogen bulb uses 29 watts, the CFL uses 10 watts, and the LED uses 5. What would be an appropriate scale to use for this data? Using a scale of 1 would be a large graph. We could use a scale of 2, but how about 5? It is generally easy to label the scale using benchmark numbers such as 1, 2, 5, 10, 25, or 50. I label my y-axis with values of 5 and then draw my bars. 40 watts for the standard bulb, 29 watts for the halogen bulb. I'm thinking I need to put 29 closer to 30 than 25. 10 watts for the CFL bulb, and 5 watts for the LED bulb. Students are then asked to graph the rest of the chart for 800 lumens, 1100 lumens, and 1600 lumens. Students must decide which scale would be appropriate for the number of watts. Students that are ready for a challenge are asked to create their graphs using 2 different scales. How are bar graphs such as these helpful? If you were selling light bulbs, would graphs such as these help you convince people to buy your product? You might share situations with your child where a salesperson used graphs to convince you of a sale. Perhaps when car buying, looking at graphs of gas mileage or crash tests. When buying appliances, comparing the cost per load of washing machines or the years of use from one brand to another. It's surprising how often graphs are used to convince us of a way of thinking. In this lesson, students organize data into a bar graph using a scale greater than 1 and interpreting the results. We accomplish this by having them use information from a chart and graphing the data using different scales.